Algebra 2 students, you've been factoring. Let's take a look at three very special forms. A squared minus 2ab plus b squared, a squared plus 2ab plus b squared, and a squared minus b squared. You've been factoring quadratic trinomials, and some quadratic trinomials fit this pattern. And these patterns you can find by using all the rules of factoring I have given you. Sometimes kids find it easier to recognize that it's one of these special forms and know that this first one is just a minus b times a minus b. The second one is a plus b times a plus b. And the last one is a minus b, a plus b. This one here we often write a plus b quantity squared, and this one here we write a minus b quantity squared. Be very careful here. Kids know that if you take 3 times x times y and square it, you get 9x squared y squared. And they'll say like, oh, you distribute. No, it's not distributive property, but you just square everything in there. That is not how these work. A minus b squared is not a squared minus b squared. It's a squared minus 2ab plus b squared. A plus b quantity squared is not a squared plus b squared. It's a squared plus 2ab plus b squared. So let's take an example that fits one of these patterns and show you how the rules or the ways we've been factoring work. So take a look at this example. If I told you 4x squared minus 12x plus 9. So there's no common factors, but if you list the factors of 4 and the factors of 9, and you look for factors of 4 and factors of 9 that combine to have a sum of 12, the only way you're going to get a 12 is a 2 and a 3, which is 6, and another 2 and a 3, which is 6. Or you're looking for the factors of 36 that add to 12, which are 6 and 6. So, for those of you that like to split the middle term, 4x squared minus 6x minus 6x plus 9, you get 2x minus 3, factoring out a 2x. Factoring out a negative 3 here, you get 2x minus 3, and then you're left with 2x minus 3 times 2x minus 3. Good. And you can write that as 2x minus 3 quantity squared. If you did that the way that I like to, which is kind of just seeing this pattern here, oh, I need a 2 and a 3. So remember the first two numbers, 2x, 2x, that's what these are saying. 2x times 2x is 4x squared. And then doesn't matter, you need 3's here. And then because this is a plus, it's minus minus or plus plus, and right there you go. Another example, let's take one of my favorite special forms, which is something like 16x squared minus 49. So 16 and 49, large numbers to multiply together and figure out all the factors of whatever 16 times 49 is. I'm not going to mess with that. But what I can do is I recognize this pattern. So when I see 16, what jumps out to me is 4. And when I see, 16x squared, I'm thinking, oh, this is what we've got here. When I see 49, I'm thinking, oh, that's what we got here. This is such a common form, such a common special form, it has a name. It's called the difference of two squares. It's called the difference of two squares because it's a difference of two squares. Yeah, I know. Makes sense, right? You're subtracting two numbers that are being squared. So your job is to recognize numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. At the very least, the first 15 squares. You should see those numbers and immediately think, I've got a square. Do I have one of these special patterns? It's a difference and there's two of them. There's no sum of two squares, so please make sure it's a minus sign. Now, how it works with the factoring rules is if you list the factors of 16 and you list the factors of 49, you're looking for numbers that when combined have a difference of 0 because there's like a plus 0x here that we don't have to write. So what numbers have a difference of 0? Well, 4 times 7 is 28 and 4 times 7 is 28 and 28 minus 28 is 0. So what we have here then is we have a 4x times a 4x. We have a 7 times a 7. And because this last number is negative, you have a plus sign and a minus sign, and you're done. It's a difference of two squares. Now, if this had been an equation where it was equal to 0, you would now solve these two, get 4x plus 7 equals 0, 4x equals negative 7, x equals negative 7 over 4. I'll do what I ask you to do. I'll write out every step. 4x minus 7 equals 0, 4x equals 7, x equals 7/4, right? Another way to have done this problem, if it was equal to 0, is say, okay, 16x squared equals 49. Now I'm going to divide by 16. X squared equals 49 over 16. Now, because there's no x term, I can just take the square root of both sides. Remember the very first video of this unit. That means x equals the square root of 49 divided by the square root of 16. Don't forget, when you put this square root inside the problem, you have to make sure that you put a plus minus in front. That's what kids will forget. That x is either positive 7/4 or it's negative 7/4. There are two answers to most quadratics. Well, let me fix that. There are two answers to every quadratic. Sometimes it's the same answer twice, but it's always two answers. And so we get this plus minus, which is a really important idea. Don't forget that plus minus when you take the square root. So your homework or your classwork today after the quiz is going to be just some basic, can you recognize these special patterns? There is benefit in going past the rules that I've taught you and knowing these special patterns. Quiz tomorrow for Algebra 2 students. Can you factor when A is not 1? Can you factor when A is 1? That's it. Just two topics for Algebra 2 plus the geometry topics, which you'll see in the geometry video. Have a good night. Peace.